Okay, hello. I hope all of you are fine. So we are here in the next week of our summer school, and I think maybe few people have still problems with the timing, especially the international participants. But please be careful while calculating the times and to be inside. And if you cannot attend the summer school online, then you need to must follow it on the recorded videos, and I will send you the quiz which is related to the first week and the next weeks. And you have to qualify that particular quiz. You need to get the answers for that quiz from the recorded videos if you haven't attended it via the Zoom. First, I need to discuss if you have any problems. Maybe a lot of you have problems in downloading the virtual machine and installing it. Installation is quite easy, but I think you have problems while the downloading it because this is a full Ubuntu system and this is about 12 point something GB in size. And but it's quite handy and easy that you have a full whole operating system inside another operating system. But if you have the problems with that, you don't have good systems and the RAM and the hard disk, as I told you in the very start, that if these are the issues, then stick with the WSL, which is the thing which install the Ubuntu distributions distros inside your Windows 11 on Windows 10. They have provided that particular option. So stick with that, or maybe some of you have installed the Ubuntu as such as a new dual boot systems, because many people they do like this. If their Windows is not supporting the WSL, then they people sometimes and their hard disk is a lot with the space, then they dual boot it. Means by restarting it, you can go into Ubuntu or you can go back into the Windows. So there are several options, but we don't have times to explore those options at the moment. Maybe in the next some summer school, I will just offer a few guidelines before it because before starting the sessions, because people they need to prepare their computer with the software and the things. But now we have to live with it. We are in this next week. In this week, we will discuss about the docking, the one-to-one protein docking by using the AutoDock. Remember one thing, there are a lot of tools for the molecular docking. Many of them, they are paid, and some of them, they are totally free. AutoDock is one of the tool which is totally free, and that is even the open source. You can customize it. It is available, and its graphic user interface is available by using the MGL tools. The file I sent you and the links I shared, and that is to install the MGL tools. So you people need to install the MGL tool into your computers, and I hope so many of you have already done that. So today we will discuss that how we can use the graphic user interface of AutoDock tool, which is ADT from MGL tools, AutoDock tool, and how we can do the docking things by using the ADT graphic user interface. You can also do that by using the Linux and operating system and commands, but there are a lot of commands. So I will not prefer you do it on command prompt until unless you are doing virtual screening, a lot of ligands, and we will do that, but we will do that using the Vina, and that will be done in Linux. Many of you have asked me that either they can use their Windows for many things. Yes, you can use that. Autodock tools, MGL tools, you can install them into your Windows system and you can use that. But that is specifically used for one-to-one docking, means one protein, one ligand, and then you dock them. And then you calculate the scores manually and everything. Then there is a Pyrex system. Pyrex you can install, that is like the AutoDock tool, and you use that. Behind the Pyrex, again, there is AutoDock, and AutoDock Vina. Both programs are there. It's making the use of only this thing. And even they have their paid version, which is the Dockman 1.0. They are using that for the commercial purpose, and they have done that. They have made their graphic user interface. For now, Autodock tool ADT, that is the most optimized one with all the genetic and other algorithms, and they are present, and we got very less errors in that. Therefore, I always prefer the ADT over the Pyrex. Okay, when we will be doing the visual screening for Windows, you can use the Pyrex. For Linux thing, I will prefer on the WSL, we will use the command-based systems because they are very easy to write the scripts, and you just put one command and everything is being done, visual screening is being done. And why you need to know the Linux? Reason is that when you people will be doing the MD simulations, in MD simulations, you have to run the Linux-based bash-based command and the Python scripts to analyze the data. And therefore, I will prefer that you people should be learning at least the WSL or the Ubuntu system along with everything. So be prepared for that and keep practicing. Today, let me share and okay, if you have any particular problem that we haven't discussed in the group or we couldn't discuss in the group, then you can ask me, just unmute yourself and I will let you unmute. So you can unmute yourself and you can tell me, or you can message me along with the course. And then in the end, we can discuss your problems, that which particular problems you people have, and then we can discuss them one by one. So let me share the screen. Let me share actually the virtual box. So we are here. This is my virtual box. So I will press enter here as I have put it into the park time. So this is essentially the screen which you can see. Okay, one thing is important which I want you people to do is that from this part, you can have a share folder attached which can converse with the window and with the virtual machine. So let me share the whole screen here and then I will let you know that how it works. Okay, here you can see that this icon particularly, it may be dull, but when you click it, share folder settings, then you will come here in the share folder settings. I have already made a folder. Mine one folder from my MacBook is shared here, which is Summer School 2026. You may not seen any folder here. How to add that? Plus sign, and then you need to select the folder. You will select the path of the folder from anywhere. You will do open and folder will be shared. You will say it auto mount and make permanent and okay. And then you can see your folder here. So this is how you can see, you can share the files between your Windows and between the virtual machines instead of just doing the things you are emailing yourself and downloading there. You can make a folder. Okay, second thing is which is important here. If you look at these things, this is share folder and this is share clipboard. If you do the bidirectional clipboard, then you can copy and paste commands from window into this virtual machine and from virtual machine into the Windows. So if sometimes you are trying to find something and you are copying from the GPT, which is running into your Windows system, and you are copying the commands, so this thing will work. You will go to device and this thing. If you want to drag the files, then drag and drop. You can do it bidirectional. Then you can just drag and drop the files here, like I have drag and drop. these files, these ligand 100 file, and this is CSV, and these are the three SDF files which I have shared with you people. So these are few things which I want to tell you. And the WSL user, they can make a folder in the home directory of their WSL Ubuntu, and you can copy and paste your files by opening your CRD drive where you have installed your Ubuntu system, and then you can copy and paste there by making the folder inside the desktop. So it's quite easy, yeah, with the WSL. And other thing is by using the command prompt, but I will not prefer with you people that command prompt may confuse you that how you will do that. Okay, for AutoDock training and for the tutorial, I will give you this particular file. But before that, why not we discuss this file, because you people need to do that. You should have done that actually the last week. I have given you these files, these mixed classes, 100 ligand file, and these are taken from this particular pubcam. And this file I have downloaded, it contains almost the 100 ligands, and metadata file, it contains smiles and classes as last time I have discussed with you people. So I have asked you to try these commands. I don't know how many of you have done that. It was quite simple. I asked you to use $2 actually. You need to just copy and paste the commands, and that's it. You need to search for it. So this is how you can have a look at how many ligands are present, how many SS means SS is a point where the ligand starts. So it will count the ligands. Then there is a head. Head means the top things. You just need to copy and paste the things. Open Babel. I don't know how many of you are able to install that, but I will let you know today that how you can install the Open Babel and other things into your system. You have installed the Conda in your system. Let me go there, how to install the Conda, this thing. Okay. I think you people have installed the Conda into your Linux system. There's a question that after opening GitHub in Ubuntu using wget command, how to use. Yeah, I'm coming to that. First, let me tell you about these environments and use of the Conda or mini Conda. So this command Conda, create something, environment, ligand. So it has to create an environment which name is ligands. It will use Python 10.0 with all requirements. Then it will take almost 2 to 3 minutes, 5 minutes, depending on the speed of your internet. And then Conda activate ligands. It will activate the environment, which is the ligand one. And then you will install these things. Pandas and matplotlib, these are the libraries which analyze the data and plot them in the graphical format. Okay, that's good. One person has done that. Okay, pip install pandas. Pip is again a Python repository. This is a background program which install the different things into your laptop into this particular environment. Then pip install audi it. And then you check by using this command that either these things are installed or not. So this is one way that how you install the things, how you activate this particular environment. So this environment is very particular now. And now you can install anything by activating the ligands. Okay. And these files, I have requested you people that why not you use these Python files and check them that either these files, these are working or not. So it should print them into the columns and the shapes. You doesn't need to memorize any of these things. AI is here. You can create the scripts like this. You just need to know what is pandas. Pandas is basically a library of the Python which is used to analyze the data. That's it. Forget about the other things. If you have got some errors or something, just go to AI and it will let you know what is the particular error in your script. Means just copying and pasting and it will let you the errors. So this Python file I asked you to run, and this is again a file I need you to make. Just copy and paste the script. It will let you know about these things you should know: molecular weight, the log P, hydrogen bonds donors, hydrogen bond acceptors. So this script actually analyzes that either these candidates, they have what is their molecular weight, what is their log P, hydrogen bond donor, acceptor. Means this is just only for practice. I need you people that in the future you make your own scripts like this and you analyze the files. For example, in the projects, I will give you some files which may contains 10,000 ligands. And I will ask you to separate the ligands which have the molecular weight less than 300 Daltons. Then you have to separate them. You need to check them. Okay, aromatic compounds, you need to separate them. Hydrogen bonds, donor, this amount, acceptor, this, separate them. What is their LD50? Separate them. So in the end, you will be able to do that. Then there is a visualization that visualize the properties. Again, we are using the pandas. PLT is basically a program which plots the graph. So matplotlib, that is a program which makes very beautiful graphs. And even you will forget about the Excel thing in the future when you will be start using the matplotlib. The quality of the graphs and everything, and then manipulations, that is really beautiful in matplotlib, which you can do that. So this script, it was going to plot some figures about the molecular weights, count them, then log P, then bar chart, scatter plot, scatter, box plot, means a lot of different things it's gonna plot you, and it's gonna save them as a PNG figures. So I need you people to run this script by copying and pasting, and then check that either is it giving you everything right or wrong. If everything is fine, you have installed your RDKit, pandas, matplotlib, then everything will be fine. Remember, first time installing these things, they may take some time. And all of this will be done on the Linux or WSL, okay? In Windows, you can run the Python files, but that is a bit complex. You need to download some IDE, and then I'm not actually concerned with that particular thing. Otherwise, even on Windows, you can run these Python scripts and get the results like the WSL. If you really want to use Windows still, and you are not understanding the Linux, then install some IDE, get help from any GPT or DeepSeek, and IDE you install for the Python. One is free one for the students, which is called PyCharm is there. And that is very good. You can run it into your system, or you can run the Jupyter notebooks, which are very good. And you can run them locally, you can run them online, but you need to learn it. It will take you 2 3 days to learn how to use IDE for Windows, and then it will be very easier for you people to use that. Okay, one thing is very important. Do remember, while using the visual screening, while using the artificial intelligence, the AI tools which are being used in chemistry, that is called smiles. Every compound, it makes a string-like structure, a combination of C's, atoms, and brackets, and it just make a string which can be automatically converted into a structure, into a 2D structure, and then you can convert it into 3D. The artificial intelligence docking tools, they use these smiles, and then they check their properties, and then even they can use it for the purpose of the docking, and even their optimization by using the certain tools. So smiles, these are the signatures, these are the strings which represent the certain compound, chemical compound. So descriptors can be calculated. So these are the descriptors. You can calculate them. There are a lot of them actually. If you look at, if you are working on certain descriptors of the chemistry and you work on them and you want to check them, that which compounds, they are aliphatic, aromatic, their molecular weight, their properties, their donor acceptors, their functional groups, you can do the things which are present into rdkit.chemistry. rdkit.chemistry is very powerful program. It has a lot of features, but this is just only an introduction to you people. So you people start using these scripts and these things. The main purpose of giving you this script is to practice that how you can make the Python files, how you can run them. Means running is very simple. Python or Python 3 and then descriptors. And this is a script in which you can extract the descriptors like the smiles, molecular weight, log P, and these four features I have used. So you can even extract them because AI sometime artificial intelligence use these descriptors to compare the ligands molecules. So it depends that how you do that. This is visualization in form of graphs. So I have given few scripts. I need you people just copy and paste this particular font into a file. Code, if you remember, I have told you code is a program in which we visualize the thing. That is VS Code. You can install them into Windows. You can install them into WSL. You can install them into Ubuntu. VS Code or code, it works everywhere. You can use that and you can check that. This is one way of making the heat maps. For example, if you have compounds about 10,000 and you want to see in one go which compounds have the proper hydrogen bond donors or acceptors, you make the hydrogen map, you make the heat map of that. And in a particular line, you can understand, okay, these are the compounds, these group of compounds, they are very good, and then you can separate them out. So again, this is the chemical space mapping is there. So these few scripts, I need you people to practice and to check that either you are getting well versed into these using the bash commands, into using the Python. So I want you to be the users of the Python and efficiently. It will help you in anything, in writing, in making the graphs of your thesis. It's very helpful. In this program, it's very helpful. By using the MD simulation data, docking data, these scripts, they are very helpful. You can even write them down. If you understand the basic strategy, then you will be able to write them down very easily. You just need to know that here things, these are the libraries. And sometimes they, if libraries are not installed, then it give you an error. Then you need to install it. But anyway, uh, you will know that with the passage of time that how the common errors which you are getting and then how to resolve them. Okay, then here comes the ligand preparation and the automation. I have given you few GitHub scripts. If you remember, I have given you two GitHub scripts. Let me open it in terminal. So one was, okay, I need to go to the library where these are present, cd pubchem. So these are the files which are present into your pubchem extract. So pubchem extract contains all these different files. I told you that I have made it in such a way that automatically you can download the chemical compounds very easily. And there is a file in which I have added the names of all the chemical compounds which I require. For example, let me open this file, the chemical compounds. I will say it. Okay, I will open it into this nano compound names. I will open this one. So I have opened it into nano in terminal instead of using the VS Code. Here you can see different chemical compounds. I have written that. If I say that I don't need these compounds, I just need one or two things or whatever I will say that I need just only, these are 31 in number. I will say I just only need these ones. And I also add other compound like asparagine, aspirin, okay, narangenin. For example, I just added that. This is an option of write out, means control O. When I will press control O, it will ask me, you have to give it a new name or the same name is fine. I will say same name is file. And then control X is to exit. Control X would be exit. Okay. And now whenever I will open this file, you can see here aspirin, asparagine. These names, these are already present here. So this is how you can change while remaining into the terminal instead of opening it into another program or not. Okay, then I ask you that why not you people look at the README file. In README file, I have given everything which is required for that. So what does it repository? I have told you that it reads the names, resolve the names from PubChem, and then download the structures in which 3D are preferred. And then we are here, it just generates structure status, properties, smiles log, and optimize the ligands for the docking thing, optimize the ligand into a single screening libraries, means into converts it into one file if you want it, and then validates the output. So this is the function of this GitHub file, which I have provided you. And then what it does, it accepts text files, CSV file, or Excel files. So you can give any of these files. And then what you need to run extract.py. So let's run it and see that how it works. I will say it extract. Let me check. Extract. I will say it Python. If I can spell it well. I will say it extract.py and I will press enter. And here you can see, depending on the speed of the internet, it has started downloading the structures from the internet. So it says that there are 28 structures, and these structures, these are being downloaded automatically from the PubChem. And even the newer structure, if they are available, and if I have spelled it well, then you can use that. You can download those structures very easily. Please mute yourself so do not create any disturbance. So here you can see that in the fractions of the second, it's downloading the compounds. So this is how the compounds, these are being downloaded. For extraction, you doesn't need to install any library, as I don't need to install any library, and it's just downloading the things. And here you can see that the new compounds, the asparagine has been downloaded, aspirin has been downloaded, narangenin has been downloaded. Okay, done 28, error is 0, and these compounds, these are present here. Even if you want, you can say it only one compound name or two compound names. If you cannot find it from the PubChem or you find it very difficult from the PubChem, write the compound name into the file, run this file, and it will work for you. Okay. Then the next in our README file, if we can see that first thing was the extraction, and if you extract the compounds, and then second thing that is the optimize.py. So I have put here different methods because this script is not only to prepare for docking but also for the DFT. So supported methods, these are the MMF 94, 94S, and it tells us that if there is aromatic, use this method, unusual atoms, use this method, standard organics, use this method. And these are the output formats which will be present here. So this is my second compound, which contains Python 3 optimize.py. So when I will run it, the optimize.py, here you can see that automatically it has started optimizing the compounds. Again, this depends on the speed of your computer. And I have made this file like this, that it shows you the energy. Before energy was this, after this, and this is the delta E of this compound, and this is the method which is used. And for every compound, method is given along with the before energy, after energy, and the delta E which is used. So this is one of the actually the beauty of this program, that it contains everything. So because we have downloaded already this library, I have downloaded them, and two compounds I have added. So they have become 33 in this folder. So it has optimized all the 33 things. Here you can see your output folders. You can go here and you can see output, and even you can see optimization results. Let's see optimization results. I will say, nano, and I will copy and paste this path. Okay. I will copy and I will paste this path, and I will press enter. Here you can see it says that optimization is done or not. These are the compounds, STF files are generated, MOL2 files are generated, and everything is ready. There is no any error which we can find it here. So this is the second script which automatically optimizes the compounds. So this is the first optimization. And usually we use this optimization if we have lot of compounds. Otherwise, on Windows, if again, I'm saying that if you don't prefer that you use the Linux or you cannot understand the Linux, download Avogadros and use this program, Avogadros, for the optimization thing. It's quite easy to optimize by using Avogadros. I think maybe Shazib has told you that in Avogadros, you can open any file. So this file is opened here. And then there is an option. There are a lot of options, crystallography and others, but we are not going to discuss that. Here is the option of E, and here is a force field you need to select by yourself. I will select this field here and I will start it. And then here you can see that it has started the optimization. And usually we use the compound, we save it when this delta E, it becomes 0.0000 something, and then we consider it that there is no any need to minimize the further energy, and this compound is ready then. So on Windows, if you want to do one by one every compound, you can use Avogadros, and then you can optimize the compounds one by one by using this thing. If there is an error due to network, then it will resume from that particular point. It will wait for the network, and but I haven't put anything inside it that it should check that how many compounds are already downloaded. So you have to run it from very start because it doesn't take a lot of time. So it usually starts and it downloads the compounds in a minute or two or three. but we can put a feature inside it that it should check that either compound is already downloaded or not, and then resume in case of the network, especially if you are going downloading the thousands of the compounds. In that case, it will help. So Avogadro's, it almost it's done. So I can stop it and then I can save it. Control S, or I can go here, save it, and this compound is now ready. So this is how you can use the Avogadro's program. So I am discussing both things, that on Windows, how you can do that, and on Linux and WSL, how you can use that, because you cannot use a lot of commands and scripts actually on Windows. So you need the Linux. Okay. And then the third thing, let me again go to README. I'm going again to README because I want you people to follow that. If you follow that, you will get that. So extract and optimize. And then I have put a feature combine, that if you just need to download and optimize everything, then just run this combine.py and it will automatically download and optimize after a few minutes, 10 minutes. If you have 1,000 of compounds, it will automatically give you the results. And it will give you a log file. So this is a combined script. It's actually the combination of these both. If I do the list of the directory, then you can see that I have this output folder. In output folder, you can check that what are the files. CSV files are here, SDF files are here, optimized files are here, and this is the log of the pipeline, that what you have done. And these are the SDF files for every compound. For example, if I go to CDS SDF files, I will do ls. Here you can see the files because we have run it many times. So it has downloaded them many times. I think 3-4 times we have done that. It automatically rename it, and then it has given me these lot of SDF files. But we can put a check here, that check that either the files these have been downloaded or not, or you can manually tweak the things, something. You can just remove all the files, or you can remove something which is with _2 or something, but I'm not gonna remove it anyway. Let it be here. Otherwise, we may end up with removing everything. Okay. So this was about the PubChem thing, that you need to PubChem extraction and you get the compounds of the different types. If I go back and if I say PDB, this was your homework actually, but you people need to do, which I'm doing here. And then again, nano, I will say readme. Oh, it has made a readme file because I have spelled it wrong. So it is readme.md. Remember one thing, in Linux and in command prompt, extension is very important. If you don't give it extension, then it may create a new file. Nano will create a new file for you people. And then you have to add the different things. So this is again a repository in which we are not going to use all the steps. We are going to use first step, download properties, fix chain selection, export for docking, and we can also use step 4 and step 5, but we are not gonna use Vina for now. We will use it by a different way. So these 5 steps, you people can practice very easily. So first, second, third step. Again, which PDB files? So you need to give it a names of the PDB files. It downloads the structures and then give their properties, identify the docking, which chain you have to use. If maybe some of you have done the docking before, I will show you manually actually in PyMOL. When you download a certain file, there are more than one chains in the file. Then you have to remove one, you have to remove the water molecules, and then you have to save the files into PDBQT. These all things, these are done by using this repository by the scripts very easily instead of manually manipulating it. Although for the Windows user, I will show you that how you can prepare the PDBQT file by using the AutoDock tools, and then you can further go with that. So what are the requirements? This is important. You need this Python, you need internet connection, you need Open Babel, and then if you want to do docking with that, you need Vina, but we are not going to do that. And for fixation, you need this PDB fixer and OpenMM. So these two things, again, these are important. So how you can install these things, you can copy and then you can paste them into your here into your you can say terminal, and it will automatically install those things because I have already these things. It is saying already satisfied thing. So these things are already installed into my terminal. So I don't need to reinstall it. But for you people, it will take some time and it will reinstall PDB Fixer and OpenMM and these packages. If you get some error in that, let me know. We have a lot of different links by which you can download these things. Okay, let's check first script. Uh, Let me check the files of the names of the PDB files which we have selected. Okay, so where are the names? PDB code, nano, PDB underscore code. It has opened these PDB files. Okay. We don't need this many files. For example, if I say that I just need only 5 or 6 or 7 files, I will just write it down here. Okay. I will Control O, file name, Control X. Okay. ls, here you can see output. Let me clear the output folder actually, because there are a lot of files have already been made here. So I will say, oh, I can put static right. So files have been removed. The directories I can also remove one by one or static by static. It depends. Okay. I need to give, I think in Mac, I need to give uh, these particular names to it. So I'm removing these files one by one. So we start the things from uh, very start. So list it. So only one file is left. So rm-rf for the directory removal, and rm is for the file removal. So you need to remember these few commands: cp copy, and rm is remove. Rm hyphen rf means directory removal. Here you can see we have nothing. We have still one file. Okay. That is the Vina batch. So we have nothing here now. In output, let me go back. Let me clear it so it will come on the top. Okay. So we have these files. So I will run Python 3. So here you can see that how easy I have made it. You just need to put Python 3 script name and all is ready to go. So it will automatically connect depending on your internet. It will connect to PDB. It will try to resolve it. Okay, sometimes PDB gets some errors because the database doesn't allow it to automatically download, especially when website is down. So you doesn't need to worry. Then if you are able to change the FTP login, then although I have given two, means I have given a backup one, but still if doesn't work after a few months, then you can change it by yourself. Okay, we have put 6 files here. Failed one, skipped one. Okay, and then let's check in output. In output, you can see any error, any skip thing, properties. Let me show you nano properties.csv. Here are the properties of these files. This is PDB ID. This is the resolution. So, and this is X-ray structure, X-ray diffraction structure. Okay. And these are the ligands which are attached to it. So I have asked the script automatically extract these things, extract which particular ligand is already bound. Is there any metal? And then where are these bound? These are the active sites where the original ligand is bound. Because sometimes what happens, if you people are doing your theses or you want to do the comparing in docking with the original ligand, how it binds, and your docking, how it works, then you need this active site. So I have automatically made it possible that this file has been is already it has selected which active site is present here. So if you will open it into Excel, then it will be shown in form of the columns and everything is separate. Okay, so properties are even here. Let me go back to CD and I will do ls. Okay, and now we got the data and we got the things. We got the PDB codes and everything. So now what I will do, I will use the second script. So I will do Python. So when you use the cursor up and down, then your previous commands can appear in the Linux, in the terminal. So in the even the WSL, so you can use your arrows to go to previous command. And then I will press tab, and then you will see the whole script name is appear. I doesn't need to type everything. Means I just put few names, few alphabets. I will press tab. It will automatically fill it down. If there are more options, it will show you the options. For example, I have written just only step and I have pressed tab. It has shown me that there are these 7 options are present. If I say 1, there is no any option is present. So 1 we have already run. So I will go to step 2 and press enter. So in the next step, what it's gonna do, that is the fixation and chain selection. So it's gonna fix the PDB files. If amino acids are missing, then it will just do the thing that it will add some loops and the structures to that amino acids. So here you can see that which chain is particularly selected. So I have given it an option, the chain which is with more amino acids and chain with the less ligands. Then you have to start it. It will start it. So I think in our output files, because we have already downloaded these PDB files, so it's gonna fix all of them. So it's fixing all of those whatsoever the files which we had in our previous the nano things. I think it's present somewhere. We haven't deleted all the outputs. Maybe the CSV files are present here. So it's just doing the chain selection and it's giving me that either this thing is particularly completed or not, if there is an error or not. Report is present here. You can check, you can have a look at the report, and then you can decide that is everything is right or not. Okay, when you put the command ls.ltr and you press enter, it will sort the things according to the time. So it's just sorting the things according to the time from when we have used these files. Here you can see, and here you can see 18 August, there's an output file, outputs, which is being modified. So this is how the things, these works that LTR, you just change it, you just sort it out. So this is the last files which were modified, PDB codes and output files. So let me clear it. I will go to ls so I can see my files. So if I go to cd outputs and I will do ls, here you can see a folder is appeared, which is named as fixed PDBs. So this is a folder with fixed PDBs. I will go there, fixed PDBs. I can see here the PDB files with the suffix underscore fixed. So these files, these are present in fixed form. Their chain is separated, water molecules are removed. You can even have a look at any file like then 1e, I can type it. Well, 1e ag.pdb. So this is the PDB file. Here you can see its header and then the everything which is the format of PDB file. If you have some experience of using the PDB files or looking at PDB files, then this is called the header, in which the different details of the PDB files, the symmetry, the crystal structure, the authors, these things are present. And at the end, then we get something which is called the coordinates. So this is the sequence. These are the heteroatoms. And then these are the helices, sheets about the secondary structures, and these are the atoms which are present. So a chain is selected now. So here we select a chain of these files. And let me go back into main folder. Okay. So let's run our third script. So here we go. So I will say step 3. Step 3 is export docking and ready PDBQT files. So this will export the very cleaned PDBQT files which are ready to run for the docking with AutoDock. This is how, especially when you are doing the docking with Vina, then it automatically generates the PDBQT files, and these PDBQT files are now ready for the docking. Let's see that it has really generated or not. I will say ls.ltr, again output folder is mainly the folder which contains our data. I will do lts.ltr. Here you can see docking ready PDBQT. A new folder is appeared. I will go to docking ready PDBQT. I will do ls. Here you can see this is a report file. This is the docking ready, and these are the PDBs, and these are the PDBQTs. I will go to PDBQT. Receptor, CD receptors underscore PDBQT, and I should say it PDBQT, and I will do ls. Here you can see these are the files, and these files are with the PDBQT. Yeah, we can do it from not AutoDock Vina. We have to use PyMOL, ROSMOL, Discovery Studio, AutoDock tool, means any program by which we use that. I will show you that, especially the Windows user, they use that, but this is, I'm showing you that automatically how you remove the things. I will again look at one file, nano1ea G PDBQT. Here you can see the things, these are changed. Upper portion is called header. And then we will go to the bottom one and the format is changed now. Especially the details which are present in PDBQT is basically the charge is added, that you add the different kind of charges. We will do that into Autodock, and then you will in the graphic user interface, and then you will get know step by step that what particular things you are adding, what charges you are adding, the gestitial charges you are adding, and then how these things they are work, because every amino acid and everything they must have. Here you can see its file. These are the atoms, amino acids, chain, chain one. Okay, and then these are the coordinates. These are the electrostatics, van der Waals, and this is Q. Means the charge on the protein that is present here. That's why this is called QT. That if there is any charged one, and by which a particular charge is added to the protein because of that particular amino acid and is not interacting with anything, then it will appear here. So this is how the things are changed, and why we need PDBQT actually. The one reason is that these programs like Autodock, it requires the PDBQT. Its requirement is that the charge should be there. So we use these PDBQT. Here you can see the amino acids number and all the atoms in one amino acids. So in nano, we can see it like this. So let me go back. So we are here somewhere. Okay. So this was a third script. Then we can do the fourth one, Python 3, step 4, and then we will run it. So it has exported the ligand, which is attached to this particular PDB file. In one PDB, there are 4 ligands are present. If you look at again, so this is important sometimes. If you are doing a lot of docking and you are comparing from the parent compound with your own docking, and you are calculating the RMSD of these two, and you are proving that your docking is fine, especially in the start, and you are checking yourself, then it's very important. Again, in output folder, we got this folder with the results, docking, ligands, everything docking, ligands and boxes. And we got here these files. These CSVs, these are the ligands in which all the ligands are present. And these are the ligands PDBQTs, that if you wanna redock its own ligand, the ligand PDBQTs will be automatically present here. So about the PDB, PDB is protein data bank. And this is, you can say, a database in which the structures of the proteins, almost all the proteins, which structure has been resolved in X-ray crystallographic form or by NMR or by the cryo-electron microscope, they are deposited in this library, in this database, and that is called PDB. And if you remember, I think I have told you that PDB can be accessed by the Google. Google can access it. I think Google may not work. I haven't used the proxy here. So PDB is, you can access it from this website, rcsb.org. I hope this will work. So RCSB hosts the protein data bank, and it has about 258,000 structures of the proteins. So you write down any name of structures, you can search it. It's automatically adding the protein structures on the daily basis. And they are integrating it with the Japan, with the Europe, and with the different databases on the regular basis. So this is how this protein data bank it works. And I told you that if you are working with only one protein, you can download it from here. You can just search the protein and then you can download the protein. And I think in the first lecture about the databases, I have told you just look at that particular video at how we can do use this particular files. Okay, here I can show you that ligand underscore manifest. I need to put extension. Okay. And then I will open it. Here you can see that it has told me that this is the PDB ID and these are the ligands from that one. And these are the PDB IDs and these are the ligands. And these are the PDB IDs and these are the ligands. Uh, Open Babel usually fail to calculize, but it doesn't matter. We are not going to use calculization. So ignore this warning. And again, this protein, it has the several ligand molecules. And so this is, you can say, a report which tell you that which file which you have used. So initially, if you want to use this script, just write PDB IDs 1 or 2. So you should know that which particular protein and how it has downloaded and how it's working, and then go to the next files and next things. Okay, then here is box manifest underscore CSV. It automatically calculates the grid boxes, the center X, Y, Z, and size X, Y, Z on the basis of the ligands which are present here. So I usually double check it, but still it has provided you this thing because sometimes your ligand molecule is just only the chlorine. So chlorine is not the ligand which is being used. Yeah, this is being done in the terminal. This terminals and Ubuntu terminals, they are totally same. There is no difference in bash thing. The bash commands, they are the equal of that. So you can use all of these commands. You can practice that by looking at the video and practice these things along with that. So these are the chains, and then these are the ligands, and these are the actually the boxes which you people can prepare. Although I will tell you people, and especially the Windows people, the use of ATRF, that how you can select the cavities by visualizing it, and how you can double check the protein, that where the cavities are present and where and how you should select the X center, Y center, and Z center of the protein and do the visual screening by mean of the AutoDock Vina. So that's very important because the people, they are doing these things manually, randomly and blindly. They do not use any of these things, that which box, which steps. Okay, we have downloaded cell structure of protein and ligands. How does pipeline identify which ligand is for which structure? Okay, this is the literature which tells you. Okay, for example, if you want to do flavonoids, all of the flavonoids which are present in PubChem, and then you need to search those, or you are following certain paper, which is, for example, on the Moringa oleifera, and you know Moringa oleifera, for example, it has the 64 compounds. You just give it the names of those 64 compounds. It will download those Moringa oleifera compounds. So then we use any one of the protein structure, and then we can do the virtual screening. This is how the virtual screening works. And then the next protein, then the next protein. So we can do it again. For example, if we want to do against the anti-inflammatory proteins, 5 or 6 of them, then instead of downloading them and then fixing them manually, you can download compounds at one site, you can download your protein on the other site, and then do the visual screening, which we will do using the Vina in the future sessions. That how we will do the Vina and do the batch docking. Actually, we will look at that. So this is how, and this is where you use these two GitHub repositories. So this was the main question, that where we are using the GitHub repositories. We can also determine XYZ coordinate of the docking grid center. Yeah, this is what we have done. This is, I am saying that this automatically has determined this script, which we have used, that it has automatically determined what are the XYZ coordinates of the ligand, of the standard ligand, which is already attached to the protein. So all results are given in this folder. Therefore, I'm asking you people that just do few protein structures, only one protein, and then run it, and then check that either the results it's giving you are fine or not. Okay. And then you can further use it for the other proteins and other things. But one thing you should remember, after it gives you the cavities and other things, to have a manual check. I will also let you know about the global docking, but for that purpose, your computer should be very good, that it will search in each and every cavity of the protein structure, and it will bind in that particular cavity. But again, it will take some time and it will require more power. So I am just telling you about all the options. The people with the high speed computers, and the people with the low speed computers, and the people with the Windows, and the people who have installed the WSLs or the Ubuntu. So we have everything for all those peoples. You're not handicapped if you doesn't have the Ubuntu. You can do these things on Windows, but you need little effort installing the IDE and learning to run the Python scripts there on Windows. So that's your job now. Just spend some hours and learn from any tutorial that how you can install and how you can run that. So I have written there that what is actually the PDBQT, that charges and atom types are basically shown in this PDBQT files. And if ligand is not valid PDBQT, docking is meaningless. Of course, that is meaningless. And I have written few scripts that even you can optimize by using Open Babel. Even my pipeline also use the Open Babels for the optimization. You can use it manually, or you can use the pipeline, depends on you. So in Windows, this is the AutoDock suite. I have also sent you the links, okay? And in Linux, you can also install MGL tools. I have given you a full tutorial of that on the YouTube, that how you can install the MGL tools into the WSL, the same way you can use it on the Linux. Okay, whenever you need to, I will give you this guide. So you follow each and every step. These are the standard docking procedures which you need to follow, and then you will do the docking thing. So in what is ADT? ADT is docking tool. Let me open these things. These particular, okay. This is command line actually, which in this WSL, which in this Ubuntu virtual machine, you can use that. I was installing different things here. So let me show you. Let me clear it. I will show you, okay, how the things are installed. So I have installed these. I have checked Open Babel is present or not. I think Open Babel was missing in the virtual machine, and so it will be missing into your WSL. So how to install it? I have checked Conda. Conda is present. Yes, Conda is present. So I have given you a tutorial video that how you can install Conda. So Conda is automatically present in my virtual machine. Pip is present. Yes, Pip is present. I have tried to give you a little fix that Pip, it can install Open Babel or not, but it's refused. It cannot install, but in MacBook it works. But in this particular thing, it refused because there is some errors in the pips and it doesn't work without any environment. So I left that. I created a Conda environment. I created Conda, create and ligands Python the same way I told you. So it has taken some time and then it has installed these different packages and these things and these libraries. So I have done it already because in this session it might be taken some time. So it has installed that. It has told me if I want to activate Conda environment, I will say Conda activate ligands. If I want to deactivate, I will say Conda deactivate. So what I did, I activated it. When I activated it, you can see instead of base, environment is changed, ligands will be shown here. If ligand is shown here, then you can say, okay, now we are in the ligand Conda environment. And then I ask it to install the pandas and matplotlib. At that time, I was away from home, and then it taken some time for the installation, but it has installed everything. So network issues when they come, see connection timeout. So it has again tried. Connection timeout, again tried. So it depends that you are working with very good internet capacity or you are just having the hotspot with your mobile. So it says that, okay, I'm trying. So, but it's kept on trying. I ask it, okay, try. And ultimately it has successfully installed everything. Pandas, NumPy, everything it has installed. So in the ligand environment, now I have installed everything. I have installed here the matplotlib. I have so all the scripts which I was showing you here in this file, these all scripts, they are now ready to work in this WSL. So I need you people to create a Conda environment. So Conda is again a very powerful thing in Python. If you people want to use it for the different things, for doing your thesis or for the bioinformatics, for the DFT things, for MD simulations, for network pharmacology, you can make your own environments, you can install the files, and you can run the things effortlessly without any errors. So this is how you can install the environments and other things. Okay, then here you can see one thing to install the Open Babel here, because Open Babel was not installed. You need to update the things, sudo apt update. When you will say sudo apt update, it will check and update the things that how many updates are present. So it update and will tell us that I am updating from internet. Again, it will take some time. And for Conda, what should we install? Anything. Even if you have less space, mini Conda is fine. Or if you are gonna use a lot of it for many things, for analysis, for statistics, for heat maps, and then Anaconda, because many features are missing in mini Conda. But for now, mini Conda is totally fine, and it will take less space comparatively. Okay, here you can see that it is installing everything, upgrading everything, and ultimately, then I have asked it, okay, activate ligands. It has activated my Conda environment. Then I given it a command, Conda install dash conda forge open babel, and it worked. Here you can see that it has installed the everything which are libraries which are related to open babel. Okay, so to check that, I will press open babel and it's saying me open babel 3.2.1 has been present. It is installed. I think previously I installed it on 14 August. So it was installed on that particular date. And by this time, so you can use it like this. So I think in one video, if you follow that, I have given you, it is on the use of the Open Babel. It contains this command. So you can follow this particular command, you can install Open Babel, and then you can run it. Open Babel is very powerful program, and it converts the format, for example, into SDA file, into MOL, MOL into SDA file. Even it generates the PDBQT, which I have used in my pipeline. So you can, you need to understand dash I, you need to put the input file name and input file type and then file name and then output. So you need to understand these options. Just look at the videos and then you'll be able to understand. Okay, then the next thing what I did, AutoDock tool is already installed in virtual machine on WSL. I hope you people have done that. And then again, here I just write down ADT, and it will take some time in slower machines. Remember, don't worry about that. And ultimately, it will be open like this. In Windows, when you use the AutoDock tool, it will be open like this. So it's very easy to open the AutoDock tool. In Windows, just go to Start, search AutoDock tool or ADT, and you can open it like this. So this AutoDock tool, this software, it contains a lot of options. The one thing which I usually prefer, first going into preferences and do the settings. So these are the user preferences. Okay, I don't need it because I'm working. It's assumed that I am copying and pasting it into the Windows. So just become angry. Okay, here you can see one thing I have set, the home directory. Where should be the home directory? Where you are putting all of your files. For example, I say that I am putting all my files into this name folder. Okay. I will just put the path of that and I will say it set. How I can check the path? In the terminal here, you can see, you will write down pwd, it will give you the path name. Okay. If I want to say that, okay, I want it into desktop. In desktop, I will check the folders. Is there any folder? Okay, there is a name folder Fias, but I want it docking. Okay. I will see docking and then I will put WPD. I will get this pathway address. I will copy and I will paste it here. So every time everything that will be, so the short keys, I don't think so. They are not working. That's another issue. But anyway, I have made it work. I have made it work. Okay. So this is the directory, which is the startup directory, which I want. I will copy it. I will paste it here and I will say it's set. So it will set this particular file. So this is important. Why this is important? Because we need to open the files again and again for the proteins and for the ligand molecules. So it will help us that how we can put these files in this particular folder, like for the docking thing. Okay, let me share only this WSL, so it will be bit, I think, bigger then. Okay, because we are just gonna work on that thing. Okay, and then cache, you can give it more depending on your own cache, storage cache, that how many PDB files you want to store. And then you will just say it dismiss. So you have set the things, you have set the directory. Now, whenever you will go to read molecule, you will see it automatically opens desktop and docking. So this is the one thing which I want to see, that where you will go the read files and it automatically shows you these files are supported. And if these files are present, then you can see them here. And then other these features, we are not gonna use that. We will use another program for that, but still you will be able to use that if you wanna use AutoDock. But I don't like AutoDock because this is sometimes the heavy programs and you need very good graphic card for that thing. So AutoDock will only use for the docking purpose. Okay, let's see what our guide says. I will prefer that you follow the guide, because if you follow the guide, then you will not get distracted. Okay, this is the exercise which I will give you, but we are not gonna exercise the things. Or okay, I will give you an overview. Why not? I will give you an overview. Okay, in ADT, files read molecule, and then you select any of the ligand molecule.stf file. Okay. Okay, let's do one thing. Let's open, or let's have the PDB files which I have made and the STF files which I have made for you people, and let's copy and paste them there. Okay, I will take this particular file and I am copying it and I am pasting. I should drag and drop instead. Okay, one thing is again very important. These two files, AutoDock 4, AutoGrid 4, they should be present, means they will make your life easier if you put them into your folder of docking. Okay, so make use of that. This is my share folder. Why not I put my things into my share folder? So I will just copy it and I will paste it somewhere here. Okay. So I don't think so. That is my share folder. That's my share folder. So I have just put it there. Let's see that it has come here or not. So setting share folder is also one thing which I want you people that you should do that, and you should learn that how to do this particular thing. You can say uh, the share folder setting. Okay, here you can see, I think I have run GitHub scripts on my other terminal, not in this Mac, although I should run them on this, but we started working on that. But anyway, let me copy and paste that particular things into my folder. So again, if you are using the share folder, let me find where my GitHub files are, because I will copy the same thing, the same files, the same PDBs which we were making. I will copy them and I will paste them. Pubchem extract. Okay. Let me copy it and let me paste it into my share folder. So share folder with just save your life. For the practice thing, what we just only need one PDB and just only need one compound structure. Let me copy it from my PDB, any PDB we want. One thing I need you people to install, that is PyMOL. PyMOL we are gonna use a lot for the different purposes. So I have copied the things into my share folder from my MacBook. Okay, there was some question. Yeah. Okay, I just copied and paste the things. Okay, in my share folder, which I was using here, I have put the things. The one file which we have run was the PDB pubchem extract, one was PDB. What I am doing, I will take only one compound, the optimized one, optimized STF, preferably the compound number 1. Okay, I will copy that and I will paste it into this docking folder. So that is my ligand. Okay, I can rename it for now for you people to get very easily to understand. Otherwise, when you will be expert, you can put any name on that. Okay, that is our ligand. Okay, and then second is PDB. We can take any PDB file, means any PDB which we want. We can take that. We can take, okay, this file or this file. Short keys do not work. I need to do copy because Mac and Linux, they have very different short keys. Do remember that. Okay. Why not I copy PDBQT instead of the PDB. I will copy both because I want to show you that how the PDBQT is made. So I will select one file, one EAG. I will copy that and I will paste it here. Okay. And also I will copy PDBQT of the same file. I will copy that and I will put it here. Okay, the PDB file, I'm just gonna rename for you people to remember. This is my protein. So I got my protein, I got my ligand, I got these two files. So input is ready now. This is my AutoDock tool. And let me show the whole screen. So I will also show you the guide. Okay. So what the guide says, go to file, read molecule, and read whatever the molecule is, edit hydrogens, edit charges, ligand, torsions, return output, and save it into PDBQT. Okay, let's do it into our this Linux thing. Read the molecule. Okay, and then we have we have to open the protein here. Oh, we are working on protein or ligand, because ligand open the molecule at hydrogen. Okay, this is for, I need to remove the protein first. We can do any, but we can go by using these things. In case of ligand, you will go to input, open, and you will open the ligand, which is into SDF format. Okay, now that is very good. We got a bottleneck here. What is bottleneck? It asks me, provide me mol2 file. I don't use SDF file, although I have already prepared that. If we go to our script files, I have already prepared those things into the mol2 files. We can use that. But if you don't have mol2 file, then what you will do, you will go to, and especially the Windows user, you will go to Avogadro's, open the STF file and convert it into mol2. And the Linux user, of course, they have the powers. They can use the Open Babel and input the mol2 static.sdf files and convert them into static.mol2 files. And even there are thousands of the compounds, they can convert them into fraction of seconds into mol2. So let me copy it. Let me paste it. Okay. For now, I'm not gonna use this ligand. I'm gonna renaming it ligand.mol2. So now it will be able to read it. When you will go to ligand, you will go to input, you will open it. You can see that mol2 file is present here. And then you can open the ligand. A ligand can be easily opened. When you open the ligand, it asks you a few things. Set up the ligand, keep the charges from mol2 file, merge the 16, there are hydrogens, 16 non-polar, detected 0 bonds, and then you will press OK. So this is your ligand molecule, which is present here. Let me go to the files here. Let me go to this guideline. So the ligand, read molecules, hydrogens, charges, torsions, and output. We have read it. Then go to hydrogens, polar only. Let me go here. In edit, we have a lot of options. Do remember, for protein manipulations, for ligand manipulations, we can use that particular thing. Hydrogens, which you want to add, all hydrogens, only polar ones. You will press OK. And then what is the next thing? Charges, gastritia charges. Again in edit, you will go to edit, charges. So these are the charges. It's saying that total gastrigious added this particular amount. So it depends on what kind of ligand it is. It adds some charges and sometimes it doesn't, depending on the structure. So this is very small molecule actually, which we have selected. Okay, then torsions. The ligand detect the root, define the rotatable bonds. So again, we go to ligand. In ligand, we have these options. The torsion angles, choose root. You can choose the root manually, or you can ask it to detect the root, means where it starts. So it has detected the root. Ligand, torsion tree, and then choose the root, and then define the rotatable bonds. Sometimes ligand is very big. So you need to define, you need to decide the number of the torsion angles, how many you want to give it, or you let it decide. that how many torsion angles it should have. You will go here, and here you can see that number of of course, this is very small molecule, so you cannot see any rotatable angle here, bond here. So you can manipulate these things. For now, I will say that just keep it as such for this compound, and even for the other compounds, it will automatically decide for you people. And for the next thing, save it as PDBQT, where ligand and output. Here you can see I have used these two options, ligand input and open it. And then I have used here edit, where I have manipulated this ligand. And again, I will go to ligand output and save as PDBQT. And here you can save it in form of the ligand.pdbqt in this particular folder, and I will press save it. And here you can see that it has made a new file which is called ligand.pdbqt. So successfully we have made our ligand. So the same things is usually done by mean of my program, which makes the things ready like PDBQT. So it depends that you want your PDBQT files ready by this way, manually checking the ligands, or you can do it automatically. So what is in the next thing? You need to check few things. Sometimes zinc is present, copper is present, cobalt is present. Then we get lot of problems. Few metal ions, they are supported by AutoDock, and lot of them, they are not supported. For that purpose, you need to manipulate, change the parameter files. But for now, we are not gonna do that. If you people have problems in the metal compound docking, especially the inorganic ones, then do contact me. I will let you know that how you can manipulate those particular compounds which contains the metals. And then missing charges are not here, no metals until intentional are added. And when you open the files, there is no any error. So these are a few things you need to check. Okay. I have given you a file, 100 ligands. No one prepares manually. So you have this option. This is a script which runs in bash. You make a file into your folder of SDF 100, and then you just convert all your files from SDF into PDBQT. And that's why I put that into SDF. So you can try this script, and it will convert all the files of SDF into PDBQT. So either this method, or you can use these scripts which I have made here. Okay. This is your assignment. I am not gonna discuss these things. These are about the admits. The admit properties, you need to work on that how you can search the admit properties and use these scripts, and you can make your own. Okay. One thing you should remember that you need to practice it again and again. I will give you the what you can say the questions and the quiz. You need to qualify that for the certificate. And if you people are watching the videos, and you are attending the sessions, and then you people will be able to attempt that particular quiz. And if you attempt that quiz, then at the end, I will just request the moderators. In few sessions, we still need some moderator, because I need that at least in every group, we should have 4 to 5, 4 at least, are the 5 are the okay moderators, so they can manage the things like the quizzes, and then they will let me know that how many people they have attempted and what's their score. Although Google will automatically check that, but still they will let me know in the end that which people I'm gonna send the certificates or not, or which people have certain problems or not. Okay, so I'm not gonna do these things these you people are gonna do. Let me go to the real-time things which I want you people to do. PDB file which you will go for the docking, that is 7E3H. I want you people to prepare that. Okay, by using the scripts, by manually. This is the active site of acetylcholinesterase. And usually we take it from the literature. So I have searched it from the literature. And I also searched the standard ligand. It binds with these particular amino acids. And this is the experimental delta G, which is found. And this is dissociation or inhibition constant of donepezil with the acetylcholinesterase. So whenever we do the anti-Alzheimer's studies, we take these things as the standard. And then we compare to our ligand that how much our ligand is good. And I have given it a complete protocol here. Yeah, these files will be shared with you people, of course. Okay, I have given you a very easy way that you need to download this particular file, the PDB file here. Means again, by mean of the scripts, not here, the terminal which is present here. So I will just copy and paste and I will press enter. Here you can see by using this one liner, you can download this file. So this file is being downloaded. So here how you can download these files, and here you can see 7E3H file has been downloaded. The other way to manipulate this file completely, you can use my script and you prepare this file. So I need you people to use that script, prepare that file, and then inspect the file in PyMOL. PyMOL, I need you people to install. So let me, okay, TIR docking 2026 CD. I'm just making a new folder for you people in which I download this file. I will paste here. You have seen it has downloaded the files from PDB. So it has downloaded the file from PDB. It should be present somewhere here. Okay. So you need to open it with PyMOL. PyMOL is a program which is the real ones which allow us to inspect the certain things. So here I have opened the protein structure by which we can prepare the files by visualizing it, because some people, they like to work, they like to prepare their own proteins by visualizing at that, by checking that either protein is fine or not. So I will go to here sec. This is the sequence and this is the chain. And these are the amino acids number on the top, and these are the one letter amino acids. As I will go forward, I can see here are certain gaps in the amino acids. And here are the water molecules which are present. And this is what you can say. This is the ligand, which is already attached. And these are the extra ligands which are attached here. So how we prepare the file? We can inspect it by using PyMOL. How we can manipulate this file? What I will say, we need to remove the chain. One chain we will keep, one chain we will remove. I will say it in this command line. remove chain A, and it will automatically, it has removed the chain A here. It depends that what kind of chain you want to remove. You want to remove chain A, you want to remove chain B. It depends on you. Okay. So Control Z works, remember one thing. So here I will remove, for example, chain B will disappear. So it depends at which chain you want to remove. Here you can see that the ligand molecule is still present here. These are water molecules. I can select them by pressing the button, or I will go on these buttons. These buttons, remember, this is action button. This is show button. This is hide. This is label, and this is color. So it depends that what button you want to select. Okay, one thing you should remember, when you click on that, it appears. When you again click, it becomes dim and it disappears. So it depends on when you have number of protein structures open here and you want to work on one of them, this is how you make them disappear or appear or work on them. Okay, the action button, why I'm showing you, either you can select these water molecules, right click and remove. This is one way. The other way is that you go here, ask it to remove water. It will remove waters. And then there are certain ligands which are present here. So I will just select these ligands. Okay, all of them. I will press remove, and the ligand molecule that will be automatically removed. Here you can see only the protein. So this is how we have prepared our protein. In the script, these things, if you remember, this thing was automatically working. Protein was already being prepared, chain was being selected automatically, and here we are doing it manually. And then we'll go to File, we'll go to Export Structure, Export Molecule, whatever it is, don't change it, save, and give it a name. I will say it protein, ACHE. Here I need to change from CIF to PDB, and I will press save. So the protein has been saved in PDB file. So this is how you manually manipulate the things in PyMOL. PyMOL is an easier program. It is present. It is free for education. You can obtain the free education license file, install it, and it makes very beautiful figures. I have a tutorial of PyMOL for you people. Maybe in the third week, we will do that separately as a separate session, that how the PyMOL works and then how we can make very good figures, very beautiful figures, the publishables by using the PyMOL thing. And usually we do it before the docking or after the docking analysis. And then you will see that how beautiful figures are made by the PyMOL program. So this is how the PyMOL program that works. But remember, PyMOL doesn't save in form of PDBQT. It saves in form of PDB. So PDB I have actually prepared. Let me copy it and let me save into my share folder. So protein is present in this share folder. Let me go here. Let me give it my password. And let me go here in the share folder and let's see that either protein is present or not. Protein underscore ACHE is present. I will copy it and I will paste it into my working folder. So protein is now present there. So this is one way that how you people get the protein and prepare the protein in PyMOL. This is all the ways are written, that how you can see the proteins, how you can view it in form of the cartoon and structures. Just go through them. and then you have a look at that, and you might have some ways that how to use the PyMOLs. There is a YouTube video of using the PyMOL. I will send you that one. Just look at that, and then we'll move forward. In PyMOL, we have done that. We have removed the waters. We have removed any other NaCl if these are present. And even on the command line, you can put this command and everything is happy. Okay. Means if you just put this command, then it will automatically converts it into the cleaned receptor PDB, and it will be changed. So it depends that if you wanna get that or not. So this is adding hydrogen and charges. So how you add hydrogens and the charges to your receptors? Again, we need ADT, read molecules, added hydrogens, polar only, charges, Gesteiger charges, we will add it, and then it will be fine. Flexible, we are not gonna do that for now. I will save it for the end, and maybe if we get some time, then we do this flexible docking. For now, we are just gonna do this the fixed one because that is easier to understand, and then you will get to know about that how you are preparing your files and doing that. Okay, and then how you prepare your Doni-Pisil? I have given this particular thing, this particular direct address. If you wanna use that one, you can use that. For example, I will copy it, I will paste it. So curl is again a program which is used to download from the PubChem. So it has downloaded, you can see the file Doni-Pisil automatically from the PubChem in form of three-dimensional conformer. So you can download it. Remember, same script I have put it into my pipeline. So you can use these things. Or what is the second option? Second option is go to the PubChem here. So this is manual method. You are going to PubChem, and then you are writing there Doni-Pisil, and then you are finding its three conformer. So Doni-Pisil. So then you will search it, and then you will go to, okay, this is my compound. Then you will go to downloads, and then you will go to save it. So this is the second thing, second way that how you can do that. And other way is downloading by curl, and just 1 second and you have downloaded it. Okay. And what it is optimization, how you can optimize it. This is manual command by using Open Babel. So you can copy it, you can paste it. It has, let me check what's the name of this compound. Okay, this is donipisil.sdf. Okay, so, oh, there is a one O extra there. I need to remove that in the start of this command. That's why I was saying that it's strange. So Open Babel will take care of that. It has said one molecule is converted. So just only 1 sec, and then you have got it, Donipisil underscore 3D dot PDB. So compound is ready. So this is how you can compound, you can convert by using the Open Babel. If you wanna add hydrogen charges by using the Open Babel, you can copy it, can paste it, and you will press enter. Here you can see one molecule is converted. Again, let's check that. Is it really converted? Yes. And it said it ligand.pdbqt. So ligand.pdbqt is ready. So this is how these commands work. I really need you people to practice these things. This file is prepared specially for that purpose, that you practice that how prepare protein files, how prepare the ligand files, what are the command prompt, what is the things which you can do by using the ADT, You can do a lot of these things here. Although I have written this method in PyMOL that how you can identify uh, the sites, but really I don't prefer. I really want you people that you just go into the literature and then you search for the files. Otherwise, I have given you a script for the PyMol, which I don't wanna show you now because this was for the PyMol session, but because it is in file, then you can use that. So, oh, it's already open. I don't need it. So here is a ligand molecule which is present. So we can select that which particular amino acids are present here, but we are not going to discuss it now. It will make you confuse a little more. I will just skip that particular part. So I need you people to use this active site for now. This active site is got from literature, okay? And even this exercises, these are got from the literature. So from literature is fine. You can get it by using the literature and then you can further use it. So I think today we will stop it here, that how we can prepare the files for the docking purpose, how we can manipulate the ligand molecules, how we can manipulate the protein molecules, how we can convert the protein molecules into the PDBQT. Uh, ADT, I also told you that it can be used for the proteins. It converts the proteins. So I will say that if I don't need the ligand, I want to prepare my protein, I will go to any protein, for example, protein.pdb. It will open a protein here. Uh, Drag and drop doesn't work, just increasing its size. So this is the protein. Okay. You can check, you can display it, you can change its color, you can see it's into the ribbon form, you can see it into surface form, you can change its color. For example, if I wanna change it by the secondary structure and I wanna say it, show me the color by mean of the secondary structure. So it will do the representation into this secondary structure and I will say it, okay, this is my protein. So even in this AutoDock tool, you can manipulate the protein like this by using these buttons. But we are not actually concerned with that. We are concerned with its manipulation. If you want to do the add the charges, you can add either Coleman's charges or Gestigia charges. It depends on you people. I will add Coleman's charges here. I will say it. Okay, these has been added. I will go to hydrogens. I will say merge non-polar hydrogens. So these has been merged. And so this is how your protein is now present here. Whenever you will go in the next steps, then you will see that how your protein that is converted into, you can say the PDBQT, but we will do it in the next step. So I'm not gonna explain it now. This is how you open your protein in PDB format into the AutoDock tool. And in the next step, in tomorrow's session, we will see that how we can use AutoDock tool or AutoDock 4 for the docking purpose. And then we will see that how we can use the Vina for the AutoDock tool running purposes. And then in the last session this week, we will analyze the docking results and how to make the figures. We will discuss that for the docking, how to analyze the interactions between the proteins and the ligand molecules. And then I will give you certain assignments that you will do the docking yourself, or you will do certain the visual screening by yourself, and then you can send me your beautiful figures which you will make from using these tools. So any quick question is welcome. Otherwise, you can ask me in the group. So if there is any question for now, or you will just gonna do practice and then you will let me know that how was it. Okay. Then see you tomorrow and the same time. Tomorrow, I hope so will have only 1 hour session. So today, because we have to discuss the previous things, the ligand manipulations, therefore it has taken a bit time. Okay, then so I will need some moderator in all groups. I have added few people in the moderator one. So I will need again in few groups at least 3, 4 people. So the things they can be manipulated. No, I will not share the folders with you people. Your own computer folder, you can share it into the virtual machine. So it's only be limited to virtual machine. So virtual machine is a complete system which you are handling. I don't have access to that. It's your system and you are working on that. I don't have any remote access in that. I cannot share any file in that. So you can use that particular O file or the share folder, or you can make the things in that. It's up to you people. So I will share the files in the group. See you then. See you tomorrow.